In this video lecture, we are going to discuss binary operations and binary relations. And they sound a bit similar and might be confusing for some of you. So let's see how not to mix them up ever again. Let's understand things with two examples. The first image you see here is of a blender, and second you see here is represents the chef. Okay, so for us, blender works as a mixer. It is going to blend things and give out some smoothie, and the chef is going to check the ingredients. Let's see how this is relevant to mathematics. First, we consider the first example, that is of a blender. Now in the blender, we are giving two inputs. First is strawberry and second is a banana. And when we mix them and blend them together, what do you expect you can get? Is smoothie. Well, now talking in terms of technical terms, we can call strawberry and banana as two separate inputs, which is giving out a new output, which is a smoothie. So now how is our maths related to this? So these two are inputs. The blender works as the operation which does the mixing magic, and the output is the smoothie, which is a brand new thing. So what is the big idea behind it? Once blended, you can't separate them. So what is this operation thing doing here is that it is taking two inputs and giving you a new output. So mathematically, we can say that two elements from a set are taken, and this binary operation concept combines or merges these two inputs to give one new element. And what is important is that the element belongs to the same set. For example, strawberry and bananas belong to the set of edible elements, and the output which we got here was a smoothie, which is another edible element. So here mathematical example would be 3 and 5. When added together, this plus sign acts as an operation and it gives you the output as 8. 8 is the new output that we are talking about, and the set here could be set of natural numbers, set of integers, set of real numbers, or whatever you want to talk. That is all about a binary operation. So what is a formal definition for that? Let S be a non-empty set. Then an operation star, the name is given as star, defined on the set S cross S. Just recall, the set S cross S is the product set of some set S should also belong to S. This is called a binary operation. When is it called a binary operation? This star, when A star B belongs to S, where A is coming from the S, B is also coming from S, and their final output, which is represented as A star B, is also coming from the same set. So let us look at this example. Is the following binary? Is the following operation binary? The star is defined by A star B equal to A on set of real numbers. So first thing, don't get confused by looking at A star B defined as A. Yes, it simply tells you that whatever be the second element or the right side element, the answer is always going to be the left side element. For example, if you are talking about two real numbers, say -1, then star, say 3, the output you are going to get is, this is your A, this is your B. The output should be what? As from the example, it should be A. A was my -1. So -1 star 3 gives me -1. That's simple. If I want to write down 3 star -1, what will I get? Now my 3 is the A, -1 is the B, and so what do I get? My new A is 3, so the output would be 3. So let us see if it is binary or not. So let A comma B belong to R. because we are taking any two elements from set of real numbers. Now this is given to us, that is A star B is equal to A. But then A belongs to set of real numbers. What did we want? We wanted this condition to be satisfied, that A star B should belong to S. Now what is your A star B? It is A. What is your S basically? S is same as set of real numbers. So your A belongs to S. That is your set of real numbers. So can I say that A star B also belongs to set of real numbers? Yes. And hence I can say that star is a binary operation. Let's look at another example. Now here M star n is defined by m minus n on A. Let's come back to the same notation. A star B is defined as A minus B on n. What is n? N is set of natural numbers. This is the standard notation used in most of the books. So if A is equal to 1 and B is equal to 2, what do you think will happen? What will be A minus B? It would be A star B is equal to A minus B, which is 1 minus 2. And what is the output? That is 1, minus 1. Does minus 1 belong to set of natural numbers? No, it does not. So what do we say? Is it a binary operation? Go back, check your definition and tell me. Absolutely not. Because the output should always belong to S. Your S was set of natural numbers here. The output for this particular example does not belong to set of natural numbers. Hence, this is not a binary operation. So, the confusion here should get cleared is that this condition that A star B belongs to S should be satisfied by each and every pair of elements belonging to S. Next, let us look at a new concept. Now, I have a rule. The rule R says dash is a standard ingredient on dash. Well, we have two pictures here. This looks like a cheese block. This looks like a pizza slice. Now, can I say here according to rule R, cheese is a standard ingredient on pizza? Does that sound relevant? Does that sound correct to you? Well, yes. So, we can say that cheese, comma, pizza, this ordered pair is related or is true. Okay, let's look at another example. Hammer and pizza. Put it in the rule R. Can I say hammer is a standard ingredient on pizza? Well, certainly not. So, here what do we say is that this hammer, comma, pizza, this ordered pair is a false ordered pair for the rule R. So, not following rule R. Hence, it is a false ordered pair. So, what is this? It is known as a binary relation. In very simple words, a rule that compares an ordered pair of elements to test if a specific link exists between them. Now let us go back and think about it. Why do we say a ordered pair? So first thing, for checking relation, you should have a ordered pair which looks like this, a two tuple where left element is here denoted as A and right element is denoted as B. Now what do we have to say here? We say that A is related to B and the notation is something like this. And when is it related? When it satisfies the given rule, capital R. Now what was our rule in the previous example? The rule was simple. It was that A is a standard ingredient on B. Now suppose I replace A with pizza and B with cheese. Now how do I read it? Pizza is a standard ingredient on cheese. Does it make sense? No. The chef will certainly not agree to this kind of an item. Or olive is a standard ingredient on pizza. Do you like it? Yes, it is a standard ingredient. The rule is satisfied. Hence, it is a binary relation. Now, swap it again. Pizza is a standard ingredient on olive. Again, makes no sense. So, the word ordered pair has this significance in the relation. Now, let us look at the formal definition. What is a relation? A relation R from a set A to B is simply a subset of A cross B. Now, what is A cross B? The elements of A cross B are written as simply the ordered pair A comma B, where left element belongs to A and the right element belongs to B, because this is the left side set and this is the right side set. You swap it, you want to write elements of B cross A, then you will have the elements as B comma A. Now suppose you want to talk about binary relation on a single set, then you simply say that it is a relation between pairs of elements of only the set S. So it will be something like A comma B, where A and B both belong to the set S. Let us look at this new example here. Let S equal to the set 2, 3, 5 and 6. And let R, that is our rule that we were talking about, means divides. So what does it mean? Suppose I am saying A comma B is a ordered pair, then it means that A is related to B, or A R B like I wrote here, or A divides B. That is the new rule. So if I want to say A divides B, for example, if I want to say 1 divides 3, that is a true relation, because you look at this simple Euclidean division here. 1 divides 3, 1 3 times gives you 3, and that is giving you a 0 remainder. So 1 divides 3 is a true relation for this rule divides. So that is how we are going to think. Now think about it. Can I say 2 divides 3? No, not with a 0 remainder. So 2 is not related to 3. Can I say 2 divides 5? No. Can I say 2 divides 6? Yes, I can. So what do we have here? 2 comma 6 is a relation, binary relation in this set S under the rule R, that is divide. So these are all possible pairs that can belong to the relation, and this is how you write down the binary relation on set S with the rule divide. This is another example. 3 times is 3 times. So what happens is that here you are going to talk about A is 3 times B. Means the left component should be 3 times of the right component. That is 3R1. So you can pause the video here and try to write down what will be your R in the comment section. Okay, so with these concepts, let's try to solve some questions here. You can pause and write the answers in comment section and check if you have got the correct answer. So we are considering two digital actions. First is hitting merge on two separate document files, and second is checking if user A is friends with user B on Facebook. What are these actions? These are your 4 options. You can pause here and check your answer. Well, the answer would be hitting merge on two separate document files means we are combining two things to get a new output, that is the blender example, and hence one is going to be a operation, binary operation. Here we are simply checking if user A is friends with user B. So checking does not give you a new output, and hence 2 is a relation. So the correct answer would be 1 is an operation and 2 is a relation. Let us look at next one. Question number 2. Let S be the set of positive integers. S starts from 1, 2, 3, 4 up to infinity. Which of the following is not a valid binary operation on set? Again, the answer would be subtraction. Something like, suppose you want to subtract 4 minus 2. You get the answer 2, which belongs to S. But if you want to subtract 2 minus 4, these both are also positive integers and they are operated by subtraction. You get a minus 2, which does not belong to S. So although some of the elements satisfy the condition, not all are satisfying the condition. Hence, this subtraction is not a valid binary operation of the set S. Let's look at the next one. 5 less than equal to 9. So what does this symbol represent here? Is it showing you a binary relation or is it giving you a binary operation? Certainly not an operation because not giving you a new output. But rather it is a binary relation because it tests a conditional link. So it can tell you whether it is a true or a false statement. It is not giving you a new output. Final question before we end the video. Which of the following represents a binary relation? You can pause here, comment your answer to get your answer checked from us. Thank you for watching.